It was 7:10 in the morning on a sticky July day in 1943, and the Lake City Ordnance Plant outside Independence, Missouri, was already rumbling like it had a pulse of its own. The place shook under the non-stop pounding of machinery. Long rows of stamping presses slammed brass blanks into cartridge cups, annealing furnaces poured out heat, and conveyor belts clattered without mercy. The air was thick with the sharp bite of metal, mixed with oil, sweat, and exhaustion. The truth was simple. America needed ammunition on a scale no one had ever pulled off before. Reports coming back from the Solomons talked about units burning through hundreds of thousands of rounds in a single week. Infantry fighting in Sicily were demanding more than supply could keep up with. Fighter squadrons over Europe emptied their .50 caliber belts so fast that ordnance officers joked it took more ammo to keep a B-17 flying than it did to build the plane in the first place. The demand felt endless, and the numbers were brutal. Washington had run the calculations and figured that to fight both in the Pacific and the Mediterranean at the same time, the country needed around 2.4 billion rounds every month. What we were actually producing at that moment wasn't even close, barely half. Inside the plant, I was 19 years old, pushing a cart stacked with brass casings toward Line 4, trying my best not to think about what those numbers really meant. People talked about it quietly during coffee breaks. Combat reports all said the same thing. Frontline units weren't holding back because supply lines were cut. They were rationing ammo because we simply weren't making enough of it. I'd only been working there about 12 weeks, but even I could feel how serious the situation was. I watched supervisors stare at production charts clipped to their boards, their faces tight. I overheard engineers arguing in low voices about bottlenecks and throughput, and I noticed something else, too, something nobody seemed eager to say out loud. The most fragile step in the whole process, the moment when raw casings had to be fed into alignment tracks before charging and crimping, was still done by human hands. The motion was repetitive, slow, and almost unchanged since the end of the First World War. By 7:20 the next shift had fully settled in. 6 women stood at the feeder table, their arms moving in tight, practiced loops. Pick, place, slide, pick, place, slide. 3 simple motions, repeated thousands of times an hour. The target for that line was 30,000 fed casings every hour, but most days it stalled around 23,000. When you stretched that shortfall across the whole plant, it added up to millions of rounds missing every single day. All it took was one cracked fingernail, one slip of the hand, or one misaligned guide rail, and everything stopped cold. I learned fast that the real enemy inside a wartime factory wasn't sabotage or bad metal. It was time, lost seconds stacking up. At 7:26, a guide rail came loose, and brass casings spilled across the floor like dropped coins. The line shut down instantly. A red warning light flashed overhead. Supervisors ran in. Mechanics rolled tool carts over. The women stepped back and wiped sweat from their faces. Nobody panicked. Everyone knew the routine. Every stoppage meant recalibration, and every recalibration meant fewer rounds rolling out the door. Somewhere in the Pacific, a Marine machine gun team was firing faster than Lake City could replace what they were using. I dropped to my knees to help collect the spilled casings, and that's when something strange caught my attention. It wasn't the mess, it was the motion, the rhythm of the women's hands as they started back up, the looping movement of wrists and shoulders. It wasn't straight or linear, it was circular, predictable, almost mechanical in its own way. I should have gone back to my cart. Instead, I stood there watching. Pick, place, slide. It wasn't a straight line. It was more like an orbit. I couldn't place why it felt familiar at first. The image hovered just out of reach, like something I'd seen years ago, maybe a diagram in a high school history book, or a museum trip I'd taken with my dad. Some kind of machine that spun to move things faster than hands ever could. I tried to brush the thought aside. It felt ridiculous. I wasn't an engineer. I was just a kid making 80 cents an hour. Still, the idea wouldn't let go, a rotating motion, multiple stations sharing the work. A circular platform that kept feeding as long as it kept turning. At 7:34, the line crept back to life. I glanced at the production clock and felt my chest tighten. Another 10 minutes gone. Another chunk shaved off the daily quota. Somewhere in Washington, some colonel would be circling the number in red and demanding explanations. I stood up, wiped my hands, and started pushing my cart down the aisle. But the thought came back stronger. A rotating system wouldn't need all that stopping and starting, a wheel instead of a line, a ring of feeders instead of a row. Efficiency gained not by forcing people to move faster, but by letting the machine handle the motion for them. The picture formed so clearly in my head that I stopped dead in the middle of the aisle. A wheel, a drum, a rotating star of loading slots. I almost laughed at myself. Then I didn't. The name hit me all at once. Gatling. The old Civil War gun that boosted its firing rate by rotating barrels instead of pushing one barrel to its limit. What if feeding ammunition could work the same way, only in reverse? What if rotation solved a problem that straight-line motion never could? I told myself it was a foolish comparison, but the idea wouldn't fade. It had a strange kind of clarity to it, like something obvious that had been overlooked for years. As I moved through the heat toward the back of the factory, I felt something I didn't quite recognize. It wasn't inspiration, exactly. It felt more like inevitability, like the answer had been sitting right there all along, and I'd just stumbled into it by accident. And if I was even a little bit right, a small improvement could ripple through the entire plant. A few seconds saved at each station, multiply that by hundreds of workers, across 12 lines, running 24 hours a day. The numbers could climb fast, maybe faster than anyone expected. What I didn't know yet was that this tiny observation, born during a jam at 7:26 in the morning, would grow into a mechanism capable of doubling Lake City's daily output. I also didn't know how far the impact would reach, beyond Missouri, all the way to Normandy, Saipan, and the skies over Europe. At that moment, all I had was a half-formed idea I barely understood. But history has a way of turning small thoughts into massive consequences. Before we go any further, I want to know what you think. If you believe, like I do, that the smallest observations often lead to the biggest shifts in history, comment the number 7. If you don't agree, tap like. And if you want to see how this idea turns into a machine that reshaped America's war production, subscribe so you don't miss the next chapter. At exactly 8 a.m., the plant whistle let out a long metallic scream that rattled the sheet metal walls and signaled the official start of the day shift. The night crew shuffled past, hollow-eyed and worn down, looking like people who'd spent 14 straight hours moving brass, oil, and steel through their hands. The day shift filtered in, stepping carefully around bins filled with warm brass casings that still gave off a sharp copper scent. Near the entrance, a clipboard hung from a nail, the morning's production numbers scratched in pencil. Units short again. On paper, the shortage didn't look dramatic, just tens of thousands of rounds missing. But those numbers didn't live on paper. They stacked up over 24 hours, overcoming invasions, over 2 oceans at war. Those missing rounds turned into something much heavier once you followed them forward. Commanders in Europe were filing reports about firefights where American platoons came dangerously close to running dry. Marine machine gun crews at Munda were chewing through ammunition belts faster than supply ships could keep up. The Army's own quartermaster studies warned that if output didn't climb by at least 20% before autumn, entire offensives could stall, not for lack of tanks or aircraft, but because there simply weren't enough bullets. By 8:07, the heat inside the plant had reached levels most office workers wouldn't believe. Lake City had never been built for comfort. It was built to produce. Tall windows trapped the morning sun and turned the place into a giant heat box. Furnaces warmed the annealing rooms. Steam rose off coolant baths, and sweat soaked through clothes before the morning was half over. Cotton headbands helped a little, but not much. Supervisors carried pocket thermometers that regularly read 97 degrees or more. The human body adjusted because it had no choice, not because it wanted to. Nobody complained. Complaints didn't put brass on belts. Complaints didn't shorten the war by a single minute. I pushed my cart across the floor, watching conveyor belts sway in rhythm and trays rattle endlessly as casings fed into the crimping dies. Between the noise, the vibration, and the constant movement, the plant felt alive, restless, almost hungry. America was fighting a war defined by distance, a war that demanded raw material instead of finesse, weight instead of elegance. To take one island in the Pacific, gunners might burn through 500,000 rounds. Destroyer escorts in the Atlantic could fire thousands in a single night fight. A flight of P-47 Thunderbolts, those same planes that devoured 50 caliber ammo during bomber escort, could empty full belts in seconds. Multiply that across squadrons in England, North Africa, and the Central Pacific, and the numbers climbed like smoke. The math didn't care how hard anyone worked. The front would always demand more than factories could comfortably supply. At 8:13, a foreman in a sweat-soaked shirt unlocked a metal cabinet and pulled out the previous day's production summary. The line graphs told a hard story. Lake City's best month so far topped out around 1.4 billion rounds. For the planners in Washington, that number wasn't just disappointing, it was alarming. Reports from Sicily said infantry companies were cutting back on training fire because they feared they wouldn't have enough ammo when it mattered. In the Solomons, platoon leaders had written home, asking their families to pressure representatives for more ammunition. It sounded dramatic, almost exaggerated, but those letters were real. I'd seen photocopies pinned to the bulletin board as reminders of what was at stake. One Marine sergeant had written, "We're running the guns hot enough to melt the jackets. Send more." I paused near line 6, while an inspector checked casing dimensions with a micrometer. 12/1000ths of an inch too wide, and the round would jam. 6/1000ths too narrow, and it failed pressure tests. Precision mattered, and precision took time. Time America didn't have. Still, it struck me that precision wasn't the real enemy. The real enemy was throughput. Making 1,000 of anything was manageable. Making 1,000,000 was hard. Making 1 billion every month was something else entirely. At 8:25, the morning briefing started. A lieutenant from the Ordnance Department read from a typed memo fresh from Washington. Consumption rates across all commands were up nearly 30%. Enemy resistance was stiffening. More artillery exchanges, more close-range firefights, more air intercepts. Ammunition was vanishing faster than planners had ever predicted back in 1942. The charts barely looked real. To support planned operations in Burma, Italy, the Marshalls, and soon, inevitably, France, ordnance plants needed to push output past 2.4 billion rounds a month. The lieutenant didn't soften the message. If the factories failed, everything else failed with them. I felt my shoulders tighten as he spoke. The gap between enough and disaster often came down to minutes. 10 minutes lost to a jammed conveyor didn't feel catastrophic inside the plant. But 10 minutes multiplied across 12 lines, across 2 shifts, across a 30-day month meant hundreds of thousands of rounds that never existed, and hundreds of thousands mattered. They were the difference between firefights won or lost, hills held or abandoned, lives saved or spent. I caught myself wondering what even a single percentage point of improvement would look like. 1% meant about 14 million extra rounds a month. 5% meant 70 million. The numbers were so big they barely felt real, yet the entire war depended on them. In the Pacific, logistics officers measured battles in tonnage delivered. Air commanders counted victories in gallons of fuel and belts of ammo. Behind every success at the front was the steady grind of places like Lake City, places where 19-year-olds pushed carts of brass beneath ceilings, dripping with condensation. At 8:33, the briefing ended and workers drifted back to their stations. I hesitated, feeling something I couldn't quite put a name to. Maybe responsibility, maybe the pressure of an idea starting to take shape. I wasn't an engineer or a scientist. I had no title and no authority. But I did have eyes. I'd noticed patterns others seemed to overlook. The looping motion of the feeders from earlier that morning kept replaying in my head. That circular rhythm, that half-buried memory of a rotating gun mechanism. The thought kept returning that the difference between shortage and surplus might not come from some heroic invention, but from the smallest, simplest change in how the work flowed. Before we move on, I want your take. If you believe, like I do, that wars are shaped more by production numbers than battlefield tactics, comment the number 7. If you disagree, hit like. And stay with the story, because the moment when Evelyn's observation turns into something real is coming, and it changes everything. At 9:11 that morning, after the briefing dissolved back into the usual thunder of machinery, Evelyn stood beside Line 4 again. The idea that had been tugging at her since dawn hadn't let go. It pressed at her like a half-remembered dream. Something obvious and ridiculous at the same time. The line was running, but it was limping. The workers' movements precise, yet strained. 6 sets of hands moved through the same circular path, again and again. The motions blended into a single routine: reach, lift, set, withdraw, repeated until fatigue became muscle memory. It looked like a straight line of work, but it wasn't. It was a loop pretending to be linear. I stood there watching for several seconds without blinking, letting the rhythm sink in and burn itself into my head. Then my breath caught, not because I suddenly had every answer, but because I finally saw the shape of the problem. A wheel, a rotating carrier. The solution wasn't in speed, it was in motion. The principle wasn't new. It had been around for close to 80 years, and yet no one in that building seemed to recognize it. At 9:14, an inspector walked past, muttering about throughput again. Yesterday's quota missed, today's already slipping. Nobody asked why the numbers always came up short. Nobody stopped to wonder whether the bottleneck was baked right into the process itself. Instead, everyone just pushed harder, more hands, longer hours, more pressure. I wiped my palms on my apron and felt a quiet flash of defiance. Trying harder wasn't going to take Lake City from 1.4 billion rounds to 2 billion a month. Doing the same thing faster didn't change the math. But changing the motion just might. When the foreman turned his back, I slipped away from the line and headed toward a scrap bin near the east wall. The bin was a graveyard of forgotten parts, broken pallets, bent metal brackets, cracked boards, old dowels, pieces nobody had needed in a long time. I dug through it, feeling the rough grain of splintered pine, the jagged ends of cut wood, the cold edge of a discarded bearing ring. I didn't know exactly what I was looking for. I just knew it had to be round, something that could spin freely, something strong enough to carry weight without shaking itself apart. The moment my fingers closed around the bearing ring, still slick with oil after months of neglect, something clicked. A wheel needed a center. This could be it. At 9:23, I ducked behind a stack of crates near the maintenance shed and dropped to the concrete floor. I laid out pieces of wood in rough shapes, 3 slats in a triangle, then 6 in a star, then 8. I tested how they might rotate around the bearing ring, picturing brass casings resting in shallow pockets along the edges. My hands trembled, partly from nerves and partly from how ridiculous it all felt. I wasn't supposed to be back there. I wasn't supposed to be inventing anything. I wasn't even supposed to be away from my feeder station. But the idea carried more weight than the rules. Time was leaking away, and so was ammunition. I'd felt the pressure of that deficit all morning. At 9:31, a mechanic stepped out of the maintenance shed and stopped short when he saw me kneeling on the floor with stray lumber and a metal ring arranged into some strange geometry. He raised an eyebrow. I launched into an explanation that barely made sense even to me. Something about a rotating conveyor, a circular transfer of load, a motion inspired by an old multi-barreled gun whose name I couldn't quite grab in that moment. He listened, skeptical but curious. Then he surprised me. He didn't laugh. He just asked, quietly, "What problem are you trying to solve?" When I said throughput, he nodded. Throughput was a language everyone at Lake City understood. At 9:37, I tried turning the makeshift star by hand. It wobbled. The slats weren't even. The bearing ring slipped loose. None of that mattered. The goal wasn't to build the final machine. It was to prove the principle. Rotational transfer instead of linear transfer. A wheel instead of a conveyor. Multiple feeders sharing the load instead of one set of hands doing everything. Each rotation could deliver a fresh set of casings to the alignment tracks without forcing workers into those tight, wrist-grinding motions that caused jams and delays. I measured the rough diameter against my forearm, maybe 26 inches, maybe 28. Big enough to carry 3 trays at once, small enough to fit into the existing framework. At 9:42, I moved to a small drafting table near the supervisor's office and sketched the idea with a dull pencil stub. A central bearing, a rotating plate, slots along the edge angled just right to cradle casings, a mechanical linkage tied into the existing conveyor motor. I didn't know the torque requirements. I didn't know the precise alignment tolerances. But I understood the most important variable: frequency. If the wheel turned 9 times a minute, each revolution could feed roughly 1,000 casings. Multiply that by 60 minutes and you were past 60,000 per hour. Add 4 wheels to a line, and the number jumped again. I blinked, startled by my own math. Even if I was only mostly right, the gains were exactly what supervisors had been begging for since spring. At 9:50, the foreman found me and demanded to know why I wasn't at my station. I held up the sketch, my voice shaking as I explained the idea. A rotating feeder, like a Gatling gun turned inside out. He stared at me, then at the drawing, then back at me, his expression unreadable. He didn't dismiss me. He didn't yell. He just said they'd test it during lunch break. Not because he believed in it, but because desperation has a way of opening doors that usually stay locked. At 9:58, I went back to my line, hands unsteady, mind racing. The machines sounded louder now. The rhythm of the feeders felt sharper, more fragile. I watched the workers move through their loops and felt a strange distance, like I was seeing the process from outside my own body. I wasn't guessing at the bottleneck anymore. I was diagnosing it, even if the wheel failed, even if the mechanics laughed it off, even if the plant snapped back to its old habits. Something had already changed. Once you see inefficiency clearly, you can't unsee it. Before we go on, there's something historians don't talk about enough. Innovation during war doesn't always come from engineers with advanced degrees. A lot of the time, it comes from people who live inside a problem long enough to feel its rhythm. If you believe familiarity breeds invention, comment the number 7. If you don't, tap like. And if you want to see what happens the first time this crude hand-built wheel gets tested, subscribe so you don't miss the next part. At 11:22, under the sour smell of coolant and brass dust, the maintenance crew cleared a narrow space beside Line 2. They didn't shut the line down. No one was willing to risk the quota on an experiment dreamed up by a 19-year-old with a pencil sketch. Instead, they carved out a small pocket of floor where a wooden mock-up could spin safely, just in case it flew apart. A loose half-circle of workers formed around the bench, some curious, some doubtful, all worn down. The foreman checked his watch and made it clear this wasn't going to be a science fair. The test had exactly 3 minutes, not 4, not 5. Lunch wasn't until noon, and the war wasn't stopping for anyone's ideas. At 11:23, Evelyn set the rough wooden wheel onto a temporary spindle the mechanic had bolted in place. It wobbled before it even began to turn. The slats were uneven, the bearing ring loose and sloppy, but that didn't matter. This wasn't a prototype meant to impress. It was proof of motion. The mechanic looped a small belt from a salvaged motor and flipped the switch. The wheel lurched, hesitated, then spun with a shaky, nervous rhythm. Evelyn placed 3 brass casings into the shallow grooves she'd carved with a pocket knife. The wheel rotated. One casing dropped cleanly into the alignment channel. Another bounced off and skittered away. The third shot across the bench and clanged onto the concrete, spinning like a coin about to fall. The workers laughed, not cruel laughter, just tired laughter, honest laughter. The wheel was too light, too fast, too uneven. It flung brass the way a child tosses marbles. The foreman shook his head and restarted the stopwatch. 2 minutes left. Evelyn swallowed, her face burning. She pressed her thumb into the recesses, deepening them slightly. She tightened the belt to slow the motor. The second rotation fed one casing correctly. Another half jammed before slipping free. The third flew off entirely. A pattern was starting to show itself, but it wasn't the one she'd hoped for. The idea wasn't wrong. The build was. And even as failure crept closer, she realized this was the exact moment when most ideas died, not because they couldn't work, but because the first attempt embarrassed the person brave enough to try. At 11:25, the foreman said time was up. Then something unexpected happened. The mechanic who'd helped her earlier stepped forward. "Wait," he said. "One more turn." The foreman hesitated, then let the clock keep running. The mechanic placed both hands on the wheel, adjusting tension, easing the speed until the rotation slowed into something calm and deliberate, like the sweep of a lighthouse beam. Evelyn placed 3 more casings. The wheel turned. One fed perfectly. The second slid halfway, caught the guide lip, and corrected itself. The third wobbled, hesitated, then dropped exactly where it belonged. A small ripple moved through the group. It wasn't success, not yet. But it was motion that made sense, motion that could be improved. At 11:26, the foreman cut the power. The crowd broke apart. The moment dissolved. The line surged back into its roar, swallowing the soft echo of Evelyn's heartbeat. She helped sweep up the scattered casings, but her mind was already somewhere else, racing through variables she barely understood: recess depth, entry angle, damping material, rotational speed. She felt that strange kind of high that comes from failing in a way that teaches instead of crushes. Still, when she returned to her cart, her hands shook. The embarrassment lingered. She imagined supervisors laughing it off, engineers dismissing it in a single sentence. If the idea had any value, someone would have built it already. At 11:35, an older woman from Line 4 approached her quietly, the same one who'd patted her shoulder earlier. She didn't speak at first. She simply placed a casing into Evelyn's palm and pointed to a faint dent along its rim. "You see that?" she said. "That's fatigue. Repetition does that. To metal. To people." She glanced toward the crooked wooden wheel still sitting on the bench. "Anything that cuts that repetition is worth a try." Evelyn nodded, too surprised to answer. She had expected ridicule. She hadn't expected support. At 11:42, she slipped away again with her sketch and sat near the empty loading dock. She began redrawing the design: deeper recesses, rubber lining for grip, a weighted ring to smooth the rotation, a metal spindle instead of wood. She recalculated revolutions per minute, scribbled numbers in the margins, crossed them out, rewrote them. Every assumption bent as she imagined a machine tough enough to survive Lake City's constant vibration. Then something clicked. She added a second wheel beside the first, then a third, a staggered rotation, a synchronized triple feed, one wheel delivering casings while another reloaded itself. Continuous motion instead of start and stop drudgery. Her pulse quickened. The idea was growing teeth. At 11:58, the lunch whistle blew and workers poured toward the cafeteria. Evelyn stood, stretching her aching legs, and looked out over the factory floor. The lines still moved with their familiar halting rhythm. The bottleneck was still there. And yet the air felt slightly different. The mechanic had seen possibility. The older woman had seen necessity. The foreman hadn't shut her down. Failure hadn't killed the idea. It had exposed its weak points. As she walked back toward Line 2, she passed the wooden wheel. It looked fragile now, uneven and crude, but she felt a strange respect for it. The first version of anything is a ghost. It exists only to be replaced. Before we move on, I want your reaction. Do you think an idea's first failure matters less than the courage to keep refining it? If you agree, comment the number 7. If you don't, tap like. And stay with me, because the next stage is where the wheel stops being a sketch and becomes a machine that reshapes an entire factory. At 12:47, long after most workers had returned from lunch and the heat inside the plant had climbed back into the unbearable range, the foreman called Evelyn up to the supervisor's platform overlooking the main floor. She climbed the metal stairs with the tight feeling of someone expecting a reprimand, not recognition. Below her, the plant thundered as always, presses slamming brass into cups, cooling fans screaming over furnaces, conveyor belts rattling under the weight of half-finished rounds. But standing on the platform were three people who didn't belong to the routine flow of Lake City: an ordnance procurement officer, a plant engineer with grease still staining his sleeves, and the mechanic who'd steadied the shaky wooden wheel. All three stared down at her sketch spread across the desk, held in place by brass casings. At 12:49, the engineer asked her to explain the idea again. She stumbled at first, then found her footing. A rotating feed reduced manual transfer. Work could be distributed across circular motion instead of forced through a straight line. Throughput didn't have to come from faster hands. It could come from smarter movement. She pointed at her revised sketch, her hands shaking from a mix of fear and adrenaline. The engineer listened without cutting her off, which somehow made it worse. When she finished, he tapped the margin where she'd drawn in a second wheel and asked a simple question: why add another one? She didn't dress it up. One wheel could only feed non-stop if the next wheel was already reloading itself. A staggered rotation meant no empty cycles, no pauses, no wasted motion. At 12:54, he traded a quick look with the procurement officer, then surprised her by asking for numbers. Not the plant's official figures, hers. The pencil math she'd scribbled in the margins. She braced herself, waiting to be dismissed. Instead, he nodded. Her calculations weren't precise, but they weren't fantasy either. If the system ran at 9 revolutions per minute, with 6 slots per wheel, and 3 wheels working in sync, the theoretical output pushed close to 100,000 casings an hour. The engineer's voice flattened as he repeated the figures, stripped of doubt. Not belief yet, but respect for the logic behind them. Even imperfect logic, he said, could point toward something worth testing. At 13 order, the procurement officer made a call Evelyn wouldn't fully understand until months later. He authorized the maintenance crew to build a steel prototype overnight. Not a production unit, just a test rig. Something solid enough to spin, strong enough to hold live casings without throwing them across the floor. A machine that could answer the question no one wanted to ask out loud. Could a 19-year-old factory worker actually break the bottleneck that had plagued Lake City for more than a year? By 13:08, the rumor had reached the floor. Workers leaned across machines to whisper. Supervisors exchanged tight, careful sentences. Rotating conveyors weren't unheard of, but a synchronized multi-wheel feed was different, untested, improbable. And if it worked, it might push Lake City closer to the impossible quotas Washington was now demanding. The women on line 4 glanced at Evelyn, their looks carrying both pride and worry. Pride that someone from the line had made it this far. Worry that failure would land harder on a girl than it ever would on an engineer. At 13:16, the plant engineer met with the line's supervisors. He unrolled Evelyn's sketch and translated it into their language. Stabilized central spindle, weighted perimeter ring, rubber-lined recesses for vibration control, incremental feed into existing channels, gear reduction to manage speed. They stared, trying to picture it. One supervisor finally asked what everyone was thinking. What if it jams? The engineer answered without hesitation. If it jams, we fix it. If it works, we rewrite the rulebook. At 13:27, as if to underline his point, Line 6 seized up again. A guide rail jammed. Half a dozen workers rushed in to clear it, losing another 7 minutes. 7 minutes meant nearly 4,000 casings gone. 4,000 rounds was the difference between a rifle platoon training or standing empty-handed. Right then, the idea of trying something, anything, new stopped being a curiosity and became a necessity. At 13:32, the mechanic handed Evelyn a scrap of steel plate. He told her the prototype would be built that night, and if she wanted changes, now was the time. He wasn't humoring her. He was pulling her into the process. She felt the weight of the steel and the responsibility at the same time. She adjusted the recess angles, deepened the curves, refined the alignment lip. She couldn't calculate formal tolerances, but she understood how human motion broke down under repetition. The design didn't need perfection. It needed relief. Throughput wasn't just numbers. Throughput was endurance. At 13:45, the procurement officer called headquarters. The message was short. Possible improvement to feeder efficiency under evaluation. No names, no credit, no mention of a teenager sketching rotational diagrams on scrap paper. To someone older, that anonymity might have stung. For Evelyn, it felt like protection. Failure wouldn't brand her. Success might reveal her later. At 13:52, the foreman gathered the workers and gave an unusual instruction. For the rest of the shift, watch your hands. Watch the rhythm. Watch where fatigue sets in. He didn't explain why. He didn't mention the wheel. But he understood something important. Innovation lands hardest on the people expected to live with it. If they recognized the flaw in the old system, they'd welcome the new one. By 14 the shift settled back into its grind. But something invisible had changed. Possibility was in the air. One supervisor whispered that the device might shave 10 minutes off every hour. Another said it could double output. A mechanic said nothing at all, but checked the alignment channels with extra care. Evelyn watched it unfold in silence, realizing that an idea born from spilled casings had turned into momentum, and momentum had a way of reshaping entire landscapes. Before we move to the prototype's first real trial, I want your take. Do you believe the biggest, war-changing innovations often come from people who were never meant to innovate at all? If yes, comment the number 7. If not, tap like and stay with me, because the night shift is about to turn sketches into steel. At 19:40 that night, long after the day shift had disappeared into the Missouri darkness, the maintenance bay behind Line 2 glowed under harsh white lights. Welding torches spat sparks. Steel rang under hammers. On a heavy workbench, slick with oil and heat, the first real prototype took shape. No wood, no wobble, no guesswork. The night crew had seen plenty of projects come and go. Most were minor tweaks, forgotten within days. This one felt different, not because anyone believed in it, but because they had run out of alternatives. Production had flattened. Washington had stopped asking for improvement and started demanding it. At 19:48, the mechanic lowered the finished wheel onto a hardened spindle machined barely an hour earlier. The plate measured nearly 28 inches across, cut from quarter-inch steel, with a stabilizing ring welded around the edge. Each slot was lined with rubber scavenged from vehicle tires to damp vibration. The wheel was heavier than expected, heavy enough that one man struggled to lift it without losing his grip. That weight mattered. In this plant, vibration killed ideas faster than heat ever could. Anything that shook itself apart wouldn't survive 10 minutes on a live line. At 7:54 p.m., the engineer arrived, his coat tossed over one shoulder, a clipboard tucked under his arm. He studied the steel prototype with the careful look of a man trying not to get hopeful too early. He took a file and adjusted the angle of one recess, brushed metal dust off the spindle, then waved Evelyn forward. She stepped in slowly, aware of every pair of eyes on the night crew turning toward her. She wasn't supposed to be there after her shift. She wasn't supposed to see any of this. But the idea had its own pull, and it hadn't let her go since morning. At 8:03, the engineer crouched beside the motor assembly salvaged from an old conveyor. Gear reduction mattered. Too fast, and the casings would fly. Too slow, and the whole thing would be useless. He tweaked the tension rod, stepped back, and said one word, quiet but clear. Ready. The mechanic flipped the switch. The motor growled. The wheel shuddered once, then settled into a smooth, steady rotation. Not perfect, but controlled. A low hum instead of a rattling death noise. The crew exchanged looks. It wasn't failing. That, alone, felt like a victory. At 8:06, the first real test began. 20 casings were placed into the recesses. The wheel turned. The brass stayed put. One by one, each casing reached the feed lip and dropped cleanly into the alignment chute. The first 10 were flawless. A few after that bounced but corrected themselves. One hesitated, then righted itself. Only one shot wide, 19 out of 20. That ratio didn't sound heroic on paper, but compared to the chaos of the wooden mock-up earlier that day, it was staggering. At 8:09, the engineer timed the cycle. If a wheel like this ran continuously on a live line, even with conservative scaling, throughput could jump from 23,000 casings an hour to more than 50,000 at a single station. Multiply that across a line. Multiply it across the plant. Multiply it across the war. He ran the math 3 times, breathing slower each time. People in Washington talked about divisions and fleets. Standing there on a concrete floor slick with oil, the war reduced itself to casings per hour, rounds per shift, minutes reclaimed, bottlenecks erased. At 8:13, something unexpected happened. A night shift supervisor, a man famous for mocking new ideas, set his coffee mug down, folded his arms, and said one word, again. They ran the wheel again and again. Different speeds, different loads, different angles. The wheel behaved almost stubbornly, as if it wanted to work. When it failed, it showed exactly where it needed help. A deeper recess here, a smoother lip there. No invention arrives complete. It fights its way into existence. This one was fighting to stay. At 8:27, the engineer pushed it harder, 30 casings, then 40, then 48. The wheel groaned, the spindle flexed. Rubber linings squealed under pressure, but it held. It wasn't pretty. It wasn't elegant. It was functional, which was the only language wartime manufacturing cared about. Lake City didn't need beauty. It needed volume. It needed endurance. It needed a way to turn brass into firepower without bleeding seconds. At 8:32, Evelyn stepped back, hardly breathing. Something rose in her chest. Not pride, exactly. More like disbelief that the idea had survived the day. It wasn't a sketch anymore. It wasn't a shaky wooden wheel. It was steel. Heavy. Trustworthy. Real. The room felt it too. Workers stood straighter. The mechanic wiped his hands on a rag and said nothing, which was his version of praise. Even the engineer, usually locked behind exhaustion, let his face soften. At 8:38, they ran the final test of the night. 50 casings, continuous rotation. The chute filled at a steady, almost hypnotic rhythm. The sound was different now, less like a factory struggling, more like a system breathing evenly for the first time. The engineer exhaled. The mechanic nodded. Evelyn closed her eyes for a moment. This wasn't victory. It wasn't even success. But it was direction. And in a war factory, direction was everything. Numbers could rise from here. Output could climb. Quotas could finally be met. And somewhere months later, on a beach, a ridgeline, or a jungle trail, a soldier would fire a weapon loaded with ammunition that existed because of this moment. Before we go further, I want your take. Do you believe real technological breakthroughs are built from hundreds of small corrections instead of single flashes of genius? If yes, comment the number 7. If not, tap like. And stay with me, because once this wheel hits a live line, Lake City's entire world tilts. At 6:50 the next morning, the plant whistle screamed over the parking lot as sunlight cut through the haze above the smokestacks. Workers streamed in, unaware that a piece of steel built overnight was about to change how their day felt. Supervisors spoke in clipped tones. Mechanics moved with unusual urgency. And at the center of Line 2 stood the new rotating feeder, bolted into place and polished just enough to keep sharp edges from slicing hands. It looked crude, heavy, overbuilt. No one would have guessed it might alter the course of a factory, producing more ammunition than any other on the continent. At 7:05, the foreman gathered the morning crew. He didn't give a speech. He just pointed at the machine. "We start slow," he said. "If it fails, we shut it down. If it works, you'll feel it before you see it." The words hung there. Workers stepped closer, some hopeful, some deeply skeptical. Machines failed here all the time. Heat warped steel. Vibration shook bolts loose. Dust got into everything. But the foreman's voice carried something new. Curiosity instead of resignation. At 7:11, the engineer checked the motor housing one last time. Gear reduction, set at 9 revolutions per minute. No more, no less. He nodded to the mechanic. Power. The switch snapped. The feeder wheel stirred, steadied, and began to turn with a slow, deliberate heartbeat. Not the frantic spin of the wooden mock-up, not the nervous wobble of last night's first steel build. Controlled, confident. The workers leaned in. Someone placed the first casings into the recesses. The wheel carried them forward, and then something remarkable happened. Instead of casings being aligned one at a time, the wheel delivered an entire cluster in a rhythm that felt almost unnatural inside that building. And for the first time, Lake City felt like it was moving ahead of the war instead of chasing it. There was no jam, no hesitation, no stop-and-start stutter. At 7:13, the line completed its first full minute running under the new system. Normally, this station struggled to push even 500 casings a minute. That morning, the counter climbed past 700, then 740, then 783. It wasn't perfect, but it was undeniable. The increase was no longer a theory. You could hear it. The alignment channels rattled faster. The workers' hands moved with less tension. The whole line seemed to breathe out, like someone had finally loosened a knot running through its spine. The foreman didn't smile, but his eyes narrowed in a way I'd seen before. The look a man gets when a problem he's wrestled with for a year suddenly stops fighting back. At 7:21, they loaded a larger batch. The wheel accepted it without protest. The rubber lining soaked up vibration. The weighted rim kept the rotation steady. Casings dropped with a metronome-like consistency that no one would have believed possible from a sketch drawn less than 12 hours earlier. Supervisors hurried over, pencils flying as they wrote down numbers. Workers traded looks that blended relief with disbelief. They were used to machines letting them down. They weren't used to machines making the work easier. At 7:30, I stood off to the side, feeling strangely removed from it all, like I was watching someone else's idea take its first steps. I noticed things others didn't. The slight drift in the wheel's axis, the brief wobble at certain slots, the tiny delay when too many casings collected at once. I filed each flaw away in my head. Improvement wasn't optional. The war didn't reward almost. Still, for the first time, I let myself take a slow breath. It worked, not beautifully, not flawlessly, but clearly. At 7:38, the plant engineer pulled me aside and asked a question I hadn't expected so soon. Could it scale? Could one wheel become 4? Could 4 become 12? Could the entire line be converted without shutting production down? I answered honestly. Yes, but not without redesigning the spindle mounts, reinforcing the stabilization ring, and reshaping the recess curves. The words came out cleaner than I expected. The engineer scribbled notes as fast as I spoke, nodding along. He'd seen promising ideas crushed by real-world constraints before. But this time, though he couldn't yet explain why, he felt they were standing at the edge of something that deserved more than doubt. At 7:44, as if on cue, the production counter hit a number Lake City had never seen at that hour. A full hour's output crossed 80,000 casings. For a moment the room went still. No cheers. This was a war plant, after all. But a charged silence, the kind that means everyone understands they've crossed into unfamiliar ground. At 7:50, the superintendent arrived, pulled from his office by the foreman's urgent call. He studied the wheel, the numbers, the smooth motion of the line, the complete absence of jams. Then he looked at me. The question in his eyes was the same one I'd already heard. Can it scale? Behind it sat another question he didn't say out loud. How many lives does this save? By 8:00 the wheel had run long enough to prove its case. The superintendent authorized immediate fabrication of 3 more units, a full redesign of Line 2, a phased conversion of the remaining lines if results held for 72 hours. A memo went to Washington, noting an experimental increase in feeder efficiency. No names, no credit, just numbers. The only language wartime bureaucracy trusted. I stepped down from the platform, feeling the vibration of the floor through my boots. Workers passed me and offered small nods, the quiet approval of people who know when the ground has shifted beneath them. I moved past the machines, past bins of brass, past the endless belts, and felt, slowly, carefully, that I belonged here in a way I hadn't understood the day before. Not because I'd solved everything, but because I dared to see the problem clearly. Before we close this chapter, I want your perspective. Do you believe wars are won not just by armies, but by factories that learn how to think differently? If yes, comment the number 7. If not, tap like. And if you want to see what happens when this innovation spreads through Lake City and pushes American output into territory no enemy thought possible, subscribe so you don't miss the conclusion.